All right, let's get right into it. We're looking at a new kind of AI that could, and I mean this, fundamentally change the speed of science itself. We're not just talking about an AI that can summarize research papers. No, no. We're talking about one that can generate brand new, completely testable hypotheses that push the absolute boundaries of what we know.
And to really wrap your head around just how powerful this is, let me set the stage for you. Imagine a race against time. A real-world scientific puzzle about antibiotic resistance is the perfect way to see what this system can actually do when the clock is ticking.
And what happened is, well, it's pretty staggering. On one side of the timeline, you have nearly a decade of painstaking, brilliant human research. The trial and error, the late nights, all leading to a breakthrough discovery. And on the other side, just 2 days. Two. The AI was given the same problem, and it reached the exact same novel conclusion, all on its own. So the question is, how on earth is that even possible?
Well, the first thing you have to understand is that this isn't about replacing scientists. Not at all. It's about giving them a superpowered research partner. This AI co-scientist is designed from the ground up for what's called a scientist-in-the-loop collaboration. Think of it as the ultimate lab partner.
So what is it, really? At its core, this thing is a complex system of multiple AIs working together, what they call a multi-agent system, all built on the powerful Gemini 2.0 model. Its sole purpose is to act like a tireless expert assistant that can read and, more importantly, reason over mountains of scientific literature to come up with new, genuinely testable ideas.
So how does it think? I think the best way to picture it is less like a single computer program and more like a super efficient digital research team, where every member has a very specific, very important job to do.
Okay, so first up in this digital lab, you've got the Generation Agent. This is the team's wild brainstormer. Its job is to dive into all the existing research out there and just come up with a flood of initial ideas and hypotheses to get the ball rolling. No bad ideas at this stage, just pure creativity.
Next, the reflection agent steps in, and this one is the tough but fair critic. It's basically a digital peer reviewer. It looks at every single one of those brainstormed ideas and puts it through the ringer, checking for flaws, making sure the science is solid, and asking that all-important question, is this really new? Then the other agents jump into the fray, and this part is so cool. They run what you can basically call a tournament of ideas. They literally have the hypotheses compete and debate against each other to see which ones are the strongest. The winners then get passed to an evolution agent, which combines and refines them to make them even better.
So you have this incredible self-improving loop, right? Generate, debate, evolve, over and over. And that's the secret sauce. That's how the AI can so quickly zero in on really high-quality, potentially groundbreaking ideas. It's not just spitting out concepts. It's actively making them better through relentless competition and critique. Okay, so that antibiotic discovery was amazing, for sure. But was it just a fluke? A one-off? Well, to find out, researchers put this system to the test on other critical real-world challenges in biomedicine.
So, for the next challenge, they gave it a really practical problem: drug repurposing. The question was simple, but the implications were huge. Could the AI find a drug that already exists and repurpose it to treat acute myeloid leukemia, or AML, which is a very aggressive and deadly blood cancer?
And would you look at that? The system proposed several candidates, including one called Cura-6, which had never even been on the radar for AML treatment before. And in the lab tests, the results were just potent. This AI-suggested drug absolutely hammered the cancer cells, dramatically inhibiting their ability to survive. I mean, this isn't just a data point on a chart. It's a potential new lifeline that was found because the AI could see a connection that we had completely missed.
All right, so next, researchers decided to really raise the stakes. They gave it a much harder problem. Not just repurposing an old drug, but discovering entirely new ways to treat liver fibrosis, a really serious disease that, right now, has very few effective options.
And again, the results were stunning. The AI identified 3 novel targets, not drugs, but the biological pathways themselves. Specifically, epigenetic targets, which have to do with how genes get switched on and off. And when they tested drugs that hit these AI-identified pathways on miniature, lab-grown human livers, they saw significant anti-fibrotic activity. I mean, they were able to reduce the disease-causing damage by a huge margin. That's a massive step forward.
So what we're really seeing here is a fundamental shift. This is not just a faster way of doing the same old thing. We're moving from the traditional, often slow, manual scientific method to a new, AI-augmented approach that operates at machine speed and machine scale. It's finding connections across different fields of science that a single human brain might never, ever see.
And this leads us to the really big picture question, right? Let's zoom out. What happens when a tool like this is in every lab, in every university? What does it truly mean for all of us when the actual pace of discovery begins to accelerate exponentially? You know, the crucial takeaway here is this. We might be entering a whole new era where AI doesn't just answer our questions, but it helps us figure out entirely new, more profound questions to ask in the first place. This isn't just about finding cures faster. It's about fundamentally redrawing the map of what is possible to know.